All right, today we're tackling a huge one, maybe the biggest idea in all of science, evolution. We're going to break down what it really is and, the story of how we figured it all out. And we're going to start with something that might surprise you.
Yeah, see, the first thing you've got to get your head around is that evolution isn't just, ancient history. It's not just about dinosaurs or fossils. It's happening right now, all around us. And believe it or not, it's happening inside you at this very second.
And to give you an idea of just how intense this is, get this. In every single gram of, your poop, there are about 10 trillion bacteria. That's a 10 with 13 zeros after it. That's more bacteria than there are stars in the entire Milky Way galaxy. And in that massive population, you get enough new mutations to basically cover the entire bacterial genome every single day. So yeah, there is a literal universe of evolution happening inside of you right now.
Okay, so how do we even begin to wrap our minds around this? Well, the key is to see that evolution is really playing out on two different levels. It's like two big ideas that are completely intertwined.
So on one side, you've got what we call microevolution. Think of this as the engine. It's the nuts and bolts, the small-scale changes happening in populations right now, from one generation to the next. Then on the other side, you have macroevolution. This is the big picture, the grand history of life that you get when that engine runs for, billions of years. It's the pattern that the engine creates. The engine's work creates this incredible journey through time, and the history of that journey, it actually shapes how the engine works today. They feed into each other.
But here's the thing. This way of thinking is actually pretty new. I mean, to really get how big of a deal this was, we need to kind of time travel. Let's go back to the world before Darwin, before 1859. Because as science saw life back then, it was a completely different planet.
I mean, just look at this. It shows you what a seismic shift this was. In 1800, scientists thought the Earth was maybe a few thousand years old. After 1859, we're talking hundreds of millions, even billions of years. Before, species were seen as fixed, unchanging, created just as they are. Afterwards, we understood they evolved from common ancestors. Extinction, people thought it was impossible. Now it was a documented fact. Literally everything about how we understood the living world was turned on its head.
So, how did this happen? How did one person spark such an incredible revolution in thought? Well, like a lot of great stories, it all started with a journey.
So, a young Charles Darwin gets on this ship, the HMS Beagle, for a 5-year trip around the world. And everywhere he looks, he sees a world that isn't static. It's dynamic, it's changing. In Argentina, he's digging up fossils of giant armadillos right in the same spots where smaller living ones are scurrying around. Then he gets to the Galapagos Islands and sees that the mockingbirds on one island are just a little bit different from the ones on the next. These were all clues pointing to change over time. But the big aha moment, the mechanism, came later, after he read Thomas Malthus's work on population. That's when the idea of a struggle for existence clicked, and he conceived of the driving force, natural selection.
Okay, so let's pop the hood on that engine of change we talked about. What really makes it go? It really comes down to two key processes. One is natural selection, and the other is something called genetic drift.
Now, for natural selection to happen, you need 4 things. It's like a recipe. First, you need variation. Individuals in a population have to be different from each other, like some are taller, some are shorter. Second, there has to be variation in reproductive success. Some individuals just have more babies than others. Third, and this is the absolute key, there has to be a correlation between the trait and that success. Maybe the taller individuals, for whatever reason, end up having more offspring. And fourth, the trait has to be heritable. It has to be something you can pass down. If you have those 4 ingredients, evolution by natural selection isn't just possible, it's inevitable. It has to happen. But what happens if you're missing that crucial third ingredient? What if there's no connection, no correlation between a trait and who has more babies? Well, then you get genetic drift. Think of it like this. You have a big jar of red and blue marbles, and you pour just a few out through a tiny hole. By pure random chance, you might end up with more red marbles in your hand. Not because being red was better, but just 'cause. That's how they happen to fall out. That's genetic drift. Change still happens, but it's totally random. So you could say natural selection is what produces these amazing adaptations, while genetic drift is kind of like evolution by lottery.
So, an adaptation really is any trait that's been shaped by natural selection to help an organism do the 2 most important things, survive and reproduce in its environment. And the solutions that this process comes up with, honestly, they can be absolutely mind-blowing.
Okay, check this out.
You've got your insect hunting bat. This little thing, flying around in total darkness, needs to find its prey. So what does it do? It lets out a sonar blast of 130 decibels. To put that in perspective, that is as loud as a 747 jet taking off. It's insane. And this, of course, creates a life-or-death evolutionary arms race with its prey, like moths.
But let's throw a wrench in the works. There's this tiny little mite that's a parasite, and it lives inside the moth's ear. Now think about the mite's problem here. If the moth can't hear the bat coming, the moth gets eaten, and the mite dies right along with it. So what's the mite's solution? How does this tiny parasite survive this nightly battle?
The answer is, it only lives in one ear. That's it. That's the whole genius plan. By leaving one of the moth's ears completely clear, the mite guarantees that its host, its ride, can always hear the bat's sonar coming. This one simple behavior gives them both a fighting chance. It's just a stunningly elegant adaptation, a perfect little truce in the middle of a war.
So that mite and its one-year solution, that's microevolution in action. Now, let's zoom out, way out. Let's see what happens when you let that little engine of change run not for a few years, but for billions of years. When you do that, you start to see this breathtaking tapestry of macroevolution, the grand history of life. And this is where it gets really personal, because it's the story that connects you to, well, everything.
And the scale of this history is almost impossible to comprehend. I mean, for billions of years, life on this planet was just single cells. Then eventually you get things like organized sex, then multicellular life, then this explosion of animal body plans. Flowers, they're late to the party. And us, human language with syntax, we literally just showed up. We are a tiny fraction of a second on the cosmic calendar.
And here's the profound takeaway from all this. This vast, incredible history, it's not something you're separate from. You're not just an observer. You are connected to every single living thing on this planet.
I mean, just think about it like this. It's really simple. You have a mother, and your mother had a mother, and her mother had a mother, and so on, right? It's an unbroken chain of parents.
Well, if you could follow that chain back, past the first humans, past the first mammals, past the dinosaurs, all the way back, that chain keeps going, unbroken, for 3.8 billion years, all the way back to the very first flicker of life on this planet.
And right there at the origin of life, something absolutely astonishing happens. The chain, it passes through that origin point and suddenly there's no parent anymore. Your ancestry connects you directly to the non-living matter of the young earth, the rocks, the water, the air, and that connects you to the abiotic matter of the entire universe.
So the point is this, and it's a big one. Not only does evolution connect you to every tree, every bird, every bacterium on Earth, but the origin of life itself connects you to the cosmos. As the saying goes, every single element in your body that's heavier than iron, it was forged in the heart of an exploding star, a supernova. You are quite literally made of stardust. And that, right there, is the profound, awe-inspiring vision that evolutionary biology gives us.